Good morning, everyone. Myself, I am G Charan from Triple E branch. Today's my Tech Talk topic on electrical measurements and instrumentation is a method to improve cathode ray oscilloscope accuracy. Introduction: Cathode ray oscilloscopes (CROs) are essentially tools for measuring and displaying electronic signals accurately. Improving CRO accuracy is crucial for obtaining precise measurements in various applications of cathode ray oscilloscopes. This presentation will explore a method to enhance cathode ray oscilloscopes accuracy. Here, cathode ray oscilloscopes were having displaying electronic signals accurately and measurements in variable applications. Importance of accuracy. Accurate measurements are vital for troubleshoot circuit issues and verifying signal integrity. Inaccurate measurements can lead to misinterpretations of data and faulty diagnosis of electronic systems. Improving CRO's accuracy ensures reliable results and efficiently problem solving of accuracy. Here, accuracy measures the variable troubleshooting circuit issues and verifying signal integrities. And in measurements can lead a misinterpretations of data and diagnosis of electronic systems. And CRO's accuracy is improving to reliable results and efficient problem solving. Calibration. Regulation calibrations of the CRO is essential to maintain accuracy over time. Calibrating the vertical and horizontal scales as well as the trigger levels ensure precise measurements. Use a high quality calibration signal source to adjust the CRO settings accurately. A calibration is a regular source in essence of CROs to maintain accuracy at a over time. Calibration is a vertical and horizontal scales as well as the several trigger levels and precious measurements and high quality signal source to adjust the setting accurately. Signal integrity. Ensuring proper signal integrity by using high quality probes and cables is crucial for accurate measurements. Check for signal distortion, noise, and interference that can affect the accuracy of the displayed waveforms. Use shielded cables and minimize the length of connections to reduce signal degradation. Signal integrity. It shows the proper integrity by using high quality. It uses the high quality probes and cables such as the accuracy measurements of crucial cables. It shows the high level probes, cables, accurate measurements, etc. And signals distortions, noises, interferences that can affect the accuracy. So displayed waveform, it shows the displayed waveforms to no, and it where uses the shielded high level cables and minimize the length of connections to reduce signal degradation. If low level of connections we're having, it can have no affected waves. Grounding. Proper grounding of the CRO and the circuit under test is important to prevent ground loops and noise. Connect the ground lead of the probe to a clean and stable ground point to minimize interferences of the probe. Avoid floating grounds and ensure a solid electrical connections for accurate measurements. Here, grounding, it is a main thing that we should do properly. Proper grounding of CROs under tested important prevented ground loops, noises, etc. Ground lead of the probe to clean and stable ground point to minimize interference, avoiding ground floating of grounds, solid electrical connections, etc. Signal averaging utilizes signal averaging to improve the accuracy of measurements. Averaging multiple waveforms reduces random noise and enhance the visibility of the signals of measurements. Adjust the averaging settings based on the desired trade-off between measurement speed and accuracy. Signal averaging. Signal averaging is to improve the accuracy of measurements in noisy environment and having multiple waveforms to reduce noise and enhance of the signal. Uh, trade-off between speed and accuracy. Probe compensation. Properly compensate the oscilloscope probe to ensure accurate voltage measurements. Use the probe compensation signal to adjust the probe setting for optimal performances. Incorrectly compensated probes can introduce errors in voltage measurements. Probe compensation is the oscilloscope probe to ensure accurate voltage measurements. It have these several levels of measurements to take the power of voltage, and the probe compensation signals to adjust the settings of the probe performance of optical, and probes were having errors in voltage measurements to compensate it off incorrectly. Temperature control. Maintain a stable temperature environment for the CRO to minimize drift and ensure accuracy. Fluctuations in temperature can affect the performance of electronic components and lead to measurement errors. Keep the CROs in a controlled temperature environment for consistent and reliable measurements. Temperature control. It has the stable temperature environment to ensure accuracy, and the performance components and lead measurements errors. Consider reliable measurements. Bandwidth limitations. Understand the bandwidth limitations of the CRO and select the approximate settings for accurate measurements. Exceeding the bandwidth limit can result in signal distortion and inaccurate waveform display. Adjust the bandwidth setting based on the frequency of the signal being measured for optical accuracy. Bandwidth is the setting of accurate measurements of limitations, and it has the limit of to use. Exceeding can result in signal distortions and waveform displays. Frequency of the measured of optical accuracy. Shielding. Implementing proper shielding techniques to reduce electromagnetic interference and improve accuracy. Shielded accuracy. Use shielding cables, grounded enclosures, and shielding materials to protect against external noise. Shield sensitive components and connections to maintain signal integrity and enhance measurement accuracy. Shielding. It is a technique to reduce electromagnetic interference and improve accuracy. By using shielded cables, grounded enclosures, shielding materials to protect external noise, and it has sensitive components of connections to maintain signal integrity and enhance measurement accuracy. Maintenance. Regular maintenance of the CRO, including cleaning, calibrations, and components checks, is essential for accuracy. Inspect the integral component for signal of wear or damage that could impact performance. Follow manufacturer guidelines for maintenance producers to ensure the longevity and accuracy of the CRO. Maintenance, regular maintenance where include cleaning, calibration and components check essential for accuracy. Sources, internal components for signs of wear damage, etc. Manufacturer guidelines for maintenance procedures, longevity and accuracy of these CROs. And the conclusion is improving cathode ray oscilloscope accuracy requires a combination of calibration, signal integrity, grounding, and maintenance practices. By following the methods outlined in the presentation, users can achieve precise measurements and reliable results, enhancing CRO accuracy, the efficiency of electronic tested and troubleshooting process of cathode ray oscilloscope. Thank you.